Okay, well this video is for experiment number 3, first order systems. More specifically, temperature measurement and first order systems in regards to measuring temperature. In this experiment, there is not much equipment, but let me just go ahead and introduce what you're going to be using. This is a hot water boiler, so there's been water in there that's been heated up to the boiling point. 2 temperature measurement devices that are used in conjunction with a LagerPro DAQ system. One is a thermocouple, so you can see a thermocouple right here. And the next one is what's called a thermistor. Both of which are temperature measurement devices. I'm not going to go into explaining too much about them because your experiment handout should explain in detail how they work. And then your computer, of course, with LagerPro system running. So the first step, well, basically what you're going to be doing is measuring the response of each of these temperature measurement devices for it going from air to hot water, and then also from hot water back to air. So the procedure is going to go as follows. First, we're going to go ahead and measure the time response for the thermocouple. So what I ask that you do is take the thermocouple, plug it into channel 1, the side of your LagerPro unit, and then take your LagerPro unit and plug it into the USB port in your computer. You should see it load, and then in a second or two, you should see that it's registering temperature. Now, because the thermocouple has a lot less mass than the thermistor, the thermocouple is going to react very quickly to temperature change, especially when going from air to water. So what I would suggest is when you go to the data collection icon here, right, click on that, set your time. I'm going to go ahead and turn away from this as I enter in numbers because I would like you to figure out how to put in, or what values to put in for your parameters. But I would suggest that for the thermocouple, since it responds very quickly, to go ahead and input a high sample rate, so basically a high sample rate for collection, and then maybe, I don't know, 4 or 5 second collection for time duration of for which you're collecting the data. And then what I would like you to do is you press start, wait for it to actually start collecting data, and once it's collected data, then take the thermocouple and place it into the water. The reason for that is you want to make sure that you don't press start after it's already started, after it's already been switched to the water. So by pressing collect first and then placing the thermocouple in the water, you'll see, you'll definitely catch the time response. So click start. You can see that it's waiting for the data. Then go ahead and stick the thermocouple in the water, and then you'll see the data collected. You don't see much of a response because you can tell the x-axis has a temperature scale up to 1500. So what I would do is actually go and left click on it. I'm sorry, it was at 1400 degrees. Go ahead and click on it, set the time scale to 100 degrees positive, and make sure that it's 0 degrees on the minimum scale. And there you can see the time response with the thermocouple. It's flat, and then you see the time response, and then it's flat again. When you're going from water back to air, you're going to have a little bit slower of a time response. So again, go ahead and I'm going to go ahead and window out of, turn away from the values that I'm entering so that you guys can discern a little bit. So if I were to go ahead and enter my data collection values, there we go. I would go ahead and do the same thing. So right now the thermocouple, as you can see, is in the water. Press collect, wait till it starts collecting, and then take out the thermocouple and you'll see the time response after you pull it out. So as you As you do that, you'll see two values that you've recorded. Now, at this point, you can go ahead and unplug your thermocouple unit and plug in the thermistor. Now, the thermistor itself has a higher thermal mass, so it is going to respond a lot slower. So that basically means is that when you change your sample rate and the length of time recorded, you can actually decrease your sample rate significantly and then increase. You can go ahead and increase the sample, the length at which you're recording data. Again, I'm going to do my best to turn the camera away from the values I'm entering so that you can troubleshoot and figure out what values to enter. It's possible you may have actually seen some numbers, but I don't really consider that a huge deal. So as you're going to go ahead and collect it, right now the thermistor is out of the boiling water. I'm going to press collect. The unit started collecting data. It might go ahead and bring up this window that says start collection will not erase the latest data. Would you like to do that? You can go ahead and just press erase and continue. You go ahead and start collecting it, and then pull the thermistor up, put it into boiling water, and you will see the time response. Again, it takes a while for it to respond, just due to the fact that it has a higher thermal mass than the thermocouple. Again, I'm going to stop this early, but you can tell that it could take a while for it to level out. And then I'm not going to show you, but you can do the same thing for removing it from hot water to air. It's going to respond slower because the thermistor responds to temperature change in air slower than it does in water, as does the thermocouple. Now, once you've collected your data, after each run, I didn't do it in this case, but every time you collect a set of data, you're going to have to output what you've collected. So I illustrated this in the video for experiment 2, but I'll try my best to hone in here. If you go to File, and then Export As Text, what it does is that it takes all the data you collected and puts it into a text file, and you can call it whatever you want. We'll call this test 1. I'll save it to my desktop, and then save. You can go ahead then and open up Excel. And when you open up Excel, you can actually call upon that text file. Again, this is things you should have seen in the last video, but I'll illustrate again just for the sake of making sure that you know where it comes from. So make sure you select desktop. I'm having a hard time finding the file right now, but the idea is that you would go to the file, you would open it up. Let me go to my computer here. It should be under desktop. There we go. And then make sure that it has all files selected. And then from there, there's the text file that I saved. Click on it. Up comes a dialog window that asks you to select how you want it to be, how you want the data to be separated. Make sure that it's separated into different columns. Press finish. And there you go. There is the time slot along with the recorded temperature for each time slot. And so you can take that and process the data according to the instructions that the experiment memo gives.